how would you, what do we got to do again to be able to graph these? Slope-intercept form. So take a minute here, put them both in a slope-intercept form. And what we'll do is I'll just pass out some rulers. And you can just pass those down. We'll be using these today. And then give you another sheet of graph paper. Just hold on to this graph paper to use for whenever we do some of the notes with graphing. Okay. Okay. What's the, Anna, could you give me this one in slope-intercept form? Okay. Jesse, do you have it? Yes, because you, negative 2x, and then you divide everything by negative 1, so 2x minus 4. Good job. Okay. And Miranda, did you get this one in slope-intercept form?
Y equals -6 plus 2x.
Let's see. Okay, so when you graph them, oops, 2/1. Okay. And then if I do this, I could have done this in a different color. But right, you can see. So do these have any solutions in common? Whoops. Let me draw that better. Okay, so no solutions in common. Okay, so sometimes that'll happen. If they're, that's not drawn very well, but if they don't, those are exactly the same slope, so they're not going to cross. Okay? Do the same thing with these two. Get them into slope-intercept form and graph them. See what happens. Okay. Eric, you have this one in slope-intercept form? Okay, good job. And then I'll do this one in, so we'll graph. That'll be, I don't have 14 on here. That was up here. But if I come down 5, so I would come down 4 and 1 and over 1. So that's going to be there. Okay. So I can do that. And then let me do this one in blue. Heather, do you have this one in slope-intercept form? Okay, say that again. You had -9. Thank you. Okay. So up 1, 2, 3 over 1, 2, 3, 4. Perfect. Up 1, 2, 3 over 1, 2, 3, 4. So we've got That's the, and usually, I'll give you ones, and I think the ones in the book usually come out to a nice, point that doesn't have fractions or decimals. So if you graph it correctly, you'll get a point where they intersect. Now, if we're not, so that's, that coordinate is 4 and 1, 2, 3, 4, 5, 6, 4, -6. Now, how could we know for sure that that point solves the system? Yes, just plug it in. You can do it in your head. So if you have 4, -6, you're going to have 5 times 4 is 20 plus -6. That does equal 14. So it's a solution of that line. It's a point on that line. Put it in here. 4y, so 4 times -6 is -24. And then you would have -12. That's going to be -36. So it works in both of them. So that's a way you can check it algebraically. That's a good way to just do a quick check in your head before you go to the next problem. Okay. One more. Graph those two lines and see what happens with those. Okay. All right, let's see what we got. Okay, Luke, do you have the first one in slope-intercept form?
Yeah. Y equals -3x minus 1.
Let's see. We would add you would subtract the 21 and divide by -7.
Oh, 3x minus 1.
Okay. And Randy, what's this one in slope-intercept form? Okay. These two are both the same line. So we've got so yes, you've got the red one, the blue one. Since they're the exact same line, how many solutions do they have in common? All of them. So would you say for your solution is, so how many would that be in common? A lot. In fact, these lines, I should be more proper. I should put my arrows on there. An infinite number of points. So what you say is infinite solutions. Okay. So just as a quick recap, when you have two linear functions, there's three different situations. Either they can have no solutions in common if the two lines are parallel. So if we have your two lines could be parallel. I should always want to put arrows on your lines. So we would say no solutions in common. You can have intersect, and you have one solution in common. Or they can just be different forms of the exact same function. If they overlap, then you would say you have infinite solutions in common. Okay. So there's just a little